All right, 8.1, exponential functions, differentiation and integration. So this chapter is all about applying the stuff from chapter 7 and actually the past few chapters and putting it all together a little bit, okay? So there are some rules with exponents and logarithms and all that wonderful stuff we did in the last chapter on how we can integrate them or differentiate them. Here's whenever we have base e, how do we differentiate when we have base e? If it's just e to the power of x, derivative of e to the power of x is e to the power of x. Simple as that. It's pretty nice, huh? But if we have something else in the exponent other than x, this stays the same. The e to the u stays the same. Whatever that u is, whatever that function is, stays the same. We multiply by the derivative of u. Being whatever's in the exponent, you multiply by the derivative of, okay? And we include that in your differentiation. We got our first example here in blue, e to the power of 3x plus 7. How are we going to differentiate that? Well, as we look at rule 2, the base and the exponent stay the same. I should write this in proper function notation where y equals. So when we differentiate, y prime equals e to the power of 3x plus 7 times derivative of 3x plus 7. What's the derivative of 3x plus 7? It's 3, right? Hopefully you remember from last time. Let's make it look a little prettier. 3e to 3x plus 7 power. That is your answer to the first example. Now here's one we have to apply past rules, okay? So we have x squared times e to the power of negative x. So we're multiplying, so we have to use the product rule, okay? Remember product rule. First term stays the same, we'll bring that down. Let's proper notation. F prime of x equals x squared, that stays the same, times the derivative of e to the power of negative x. So it's going to be just e to the power of negative x times the derivative of the exponent, which is negative 1. Plus, e to the power of negative x stays the same. Then you multiply by the derivative of the first term, which is 2x. Let's make that look a little nicer. So I'm going to bring that negative up front. Negative x squared e to the power of negative x plus 2x e to the power of negative x. That is your solution. All right, I want you to find the relative extrema of this function here. So when we find the relative extrema, we need to find the derivative, okay? This looks more complicated than what it actually is because we see the division sign, right? But really, we're dividing each individual term by 2. So I'm going to change this to 1/2 e to the power of x minus 1/2 e to the power of negative x. That'll help us make this look a little prettier. So then we can find the derivative of each term individually. So it's going to be just 1/2 e to the power of x. We've got a negative sign there, so I can bring the negative and multiply it. So plus 1/2 e to the power of negative x. Now, you may use your calculator for this, okay? And what you're going to do with your calculator is find when this function's 0. What values make that 0? Now, there's no value that makes our derivative function 0 if you use your graphing calculator, okay? And that's okay. So what does that mean for us? That means, one, there's no relative extrema, but if there was, hypothetically, if there was, what does that mean for us? Well, it's going to mean that if we had whatever x value that made this function 0, we'd plug it back into here to find what that is. But we don't, so we are done. There's no extrema. We'll just say no extrema. Here are your differentiation rule, or anti-differentiation rules, rather. Similar to derivative. So the derivative is just going to be the same, and so is the antiderivative. We're going to be using a lot of, for when we have not x in our exponents, when we're finding the antiderivative of it, you're going to be doing a lot of u substitution, similar to what you did when we did integration 2 chapters back. So we got 2 examples right here. So I'm going to set u equal to the exponent, which is negative x to the 4th. Du is equal to negative 4x cubed. Dx, and then when we do that, I want to know what dx is, so I'm going to divide by negative 4x cubed, divide by negative 4x cubed, and then I'm going to substitute, if you recall, we were substituting that in for dx. So it'll be integration, we're substituting in u, in for negative x to the fourth, so it'll be e to the u rather, and then we're going to substitute in the du over negative 4x to the third. Negative 4x to the third divided by negative 4x to the third cancel, so I'm just integrating e to the u du, which is this e to the u plus c, and then we put in our u, so that will be e to the negative x to the fourth plus c. Similar process to the second one here, except it's definite integral, so we're going to have to plug in numbers at the end. So it'll be u equals negative 2x. Means du is equal to negative 2 dx. I want dx by itself. I should have put dx right there. My bad. Sorry, I should have dx in the original problem. Divide by negative 2. Du over negative 2 is equal to dx. Substitute in for dx and for u, so it'd be the integral from 0 to 1 of eu, and then we substitute in for dx, so it'd be du over negative 2. To make our integration a little easier, I'm going to move that over negative 2 up front, so we're integrating just e to the power of u du from 0 to 1. Actually integrate it, and you get negative 1/2 e to the u plus c. Actually, there's no plus c because it's a definite integral, and also we need to substitute in u. So put in u, we're going to get negative 1/2 e to the power of negative 2x, and we're evaluating that from 0 to 1. When you put 1 in, you're going to get negative 2, so it'd be negative 1 over e to 2e to the second. Because it was negative 2, I put it in the denominator to make it not negative anymore. And we put 0 in, anything to the 0 power is 1. So 1 times negative 1/2 is negative 1/2, so it'll be minus negative 1/2, so it'll be plus 1/2. And that's how you do those two problems. Let's try u substitution again for this one here. So let's make that 1 minus e to x du is equal to negative e to the x dx. Divide by negative e to the power of x. Du is over negative e to the power of x equals dx. Substitute that in. We're going to get the integral of e to the x times u, I'm going to substitute in u, times du over negative e to the x du, or I already wrote du, haha. And then the e to the x is canceled, boom, boom. I have a negative though, so I'm going to put the negative up front, so negative integral of u du. This is from previous, right? So you're going to put in, so you're going to integrate, which will be u to the power of 2 over 2. Hopefully you remember that from way back when, plus c. Then we can substitute in u. So negative 1 minus e to the power of x squared over 2 plus c. If you don't remember your integration rules, I recommend that you go back to your notes to a couple chapters ago and remember integration. All right, I hope you enjoyed, and we'll see you in class. Bye-bye.